Hello student, I am Arnab Das. Today we meet together for continuing our topic for the information theory, and entitled today's topic is average information content, or also named as a entropy for a zero memory source. A zero memory source or a discrete memoryless source is the one in which the emission of the current symbol is not dependent on the emission of the previous symbol. That means there no memory unit will be present to store the previous data. If we consider that kind of source, that means the memoryless source where number of symbols are total n, and we consider the name as form, this is s1 s2 up to sn, with their respective probability as a p1 p2 pn. That means for the s1 symbol the probability is p1, for the s2 symbol the probability is p2. In such way, for the sn symbol the probability is p of n. If we consider the message of length L, and we are interested to identify the calculate the value for the entity, that is the average information content. So for the L length message, there can be present S1, can be present S2, can be present S3, in such way can be present Sn. What number of symbol will be there for the S1, what number of symbol will be there S2, it will be depend on the probability of that particular symbol. If we consider for the S1, for that particular message, the number of S1 symbol will be present P1 into of L. Why? The probability for the S1 symbol is P1 and length of the message is L. So the number of S1 symbol will be as a P1 into of L. Same way, if you consider for the S2 symbol, how many number will be present for the L length message? It will be P2 into of L. Why? The probability for S2 is P2 and the length is the L. So P2L will be the number of symbol for the S2 to create the message L. Same way, if we consider for the Sn symbol, the number of Sn symbol will be P and L to create the message of length L. For the previous day class, we already know that the self information for an symbol. If we consider for the S1 symbol, the self information symbol will be in the bit unit as a log 2 of 1 by of P1. P1 is the probability for the S1 and 2 is here used due to the reason of we are interested to calculate the value for the self information into the unit of bit. If we consider for the other one as a R value, that time the unit will be different one. Same way, you can also say for the I2 also, it will be that time log of base 2 as a form of 1 by of P2. Now, if we think each symbol for the S1 conveyed information log 2 by of 1 by of P1, which is already known by us, bit, and such P1L, the number of S1 symbol present on an average in a length of L. That means the message length is L and their number of S1 symbol is there P1 of L. So what will be the total information conveyed by the symbol of type S1? This is the total conveyed input. Obviously, for the single one, if it is the log of 2 of 1 by P of 1, so P1L number of S1 symbol, it will be just multiply with the individual self information. That means the value will become as a P1 into L log 1 by of P1 for the base of 2 as a unit of bit. Same way, if we consider for the S2, that time the value will be, that is the total information conveyed by the symbol of type S2 will be P2L log of 1 by P2 base of 2. Same way for the symbol of Sn, it will be Pn into of L log of 1 by of Pn base of 2 as a unit of bit. For the previous day class, we already know that a fact for the information also, that is the information conveyed by composite statement which is independent is simply given by the sum of the individual self information content. And for this we just through an analogy also apply, that is the superposition theorem. So if we consider the sum of all this information content, then we can say that this is the total information conveyed by the source. Individual one we can calculate previously, that is the for the S1 it is the P1L into of log of 1 by P1. For the symbol of S2 it is the P2 into of L log of 1 by P2. So if individual term if you added on there, that time you can got the total information, that is the I of total. Thus, the average information conveyed by the source by the emitting L symbol is denoted by its entropy Hs, which is given by, this is I total by of L, because already for a title we also told that this is the average information. To get the average, so obviously how many number of message length, if you just divide, that time automatically the average information conveyed will be, because total information conveyed we calculate, so average will be just divide by the message, that is the L on there. If you divide by the L of I of total, that time the value will become there each and every term that the L term is present for information. Look that here L is present, here also L, here also L. If you common this L, then numerator and denominator L will be cancel each other. So ultimately the value of H of S will become this one. So if you write down as a simplified version of form, and the unit is the bit, that time the H is the average information conveyed, or also named as a entropy. It will be Hs, that is summation of k equal to 1 to up to n for the pk into of log 1 by pk base 2 bits per symbol. So I think each and everyone can able to understand the what is the average information, or also entropy for the source. And obviously in this case you have to remember that this is a discrete memoryless source where no memory unit will be present on there. So now take an example by which this uh, formation or this explanation will be little more effective to you also. Let there an example where the discrete memory source emit the 5 symbol and in the interval of 2 minutes per 2 millisecond. The symbol probability individual one is that 0 0.5, 0 0.25, 0 0.125, 0 0.0625, and another one also 0 0.0625. The question is that you have to find the average information rate of the source. Symbol rate is given as 2 millisecond for every symbol, and the individual probability is P1 is given to you, and the question is that average information rate you have to calculate. So how you got? Initially you have to calculate the entropy or average information content for the source. So you just apply the formula which is already we derived, that is the Hs is equal to k is equal to 1 to up to n pk log 2 of 1 by of pk, where k already we know that this is the 5. Why this is 5? The question is given to that their number of symbol is 5. So for this reason n is represented as a 5. So if you put the individual value for the first probability is 0.5, so you just put the probability 0.5, second one is the 0.25. In such a way you can write down the expression, and now by using your calculator the value will be lastly come as a 1.875 beats per symbol. Now this is an important formula, you just note down this one also. This is the important formula, that is the RS, capital RS, which is defined the average rate of information. Average rate of information is defined by the capital RS equal to HS. Already know that HS is defined the entropy. HS is entropy, and RS, small rs, it is defined the symbol rate, and which is given to you that 2 millisecond per symbol. So what will be the rate then? 1 by of 2 millisecond. That means here the symbol rate will be as a 1 by of 2 millisecond. So it will be 500 symbol per second. It is the R of S value. If you individual Hs and Rs value put this equation, that means in this equation if you put the value this one for the Hs and this one value for the Rs, that time lastly the value will become for the Rs equal to 9 point, sorry, 937.5 beats per second. So average rate of information or capital R is equal to this one. So I think each and everyone can able to understand what is the entropy, and also can calculate the value for the entropy and also the average rate of an information. So today, thank you, and again we meet together with the new topic. Okay.